Hey everyone, today we are going to solve the problem of the day, which is ugly number 2. So an ugly number is a positive integer whose prime factors are limited to 2, 3 and 5. And we have to find the nth ugly number. So from this information, what we can gather is all of the ugly numbers are composed of the building blocks which are 2, 3 and 5. And 1 is also an ugly number. So we have to start from 1 using these building blocks. We have to form all of the ugly numbers till we get to n. So how we can do that is basically we are given 1, right? So we use the building blocks which are 2, 3 and 5 and to form other numbers. And while so we expanded 1 here. So while expanded the next number, we have to consider which one is the minimum out of all of them, since we want the sequence in the ascending order, right? So after using 1 and creating 2, 3 and 5 from it, we will find the smallest. So to find the smallest, we can use a priority queue or a heap, min heap, to give us the smallest current ugly number. So that's one thing. Now the second thing we want to avoid is to pushing the same number twice in the priority queue, since that will basically affect the ugly number count. So basically what we are maintaining is each time we pop an element out of the priority queue, we know that this is the ith uh, ugly number. So first time when we pop, we have so I is equal to 1. So this is the first ugly number. Second time when we pop, we'll pop 2. So this will be a second ugly number. So suppose the test case said 2, then we'll have to stop here. So each time what we have to do is we have to first pop the element from the top, then increment our ugly count. So basically ugly number count. And whenever the ugly count reaches to n, we return the number which we have popped. So how the algorithm will go is we'll first take this, put it in the priority queue. So only this will be there in the priority queue and also mark it as visited. Now we have to generate all of these three from it. Then this is also popped from this indicates that we have popped it from the priority queue. We generated and we pushed it to the priority queue. Also marking the ones generated 2, 3 and 5 as visited. Now, which is the minimum? Priority queue will tell us that 2 is the minimum. Okay. So for 2, we'll apply the same algorithm. We'll pop it from the priority queue and generate its corresponding values. So which will be 4, 6 and 10. We'll push them into our visited. So this is a set which we are maintaining to ensure that we don't push the same values twice. Okay. Now we have done that, which is the third minimum. So basically the priority queue will tell us that 3 is now the next minimum. So similarly, if we keep on recursively applying this algorithm, we'll get to a point where our number, the number we popped, is the nth number. So the n is 10 here, I guess. Yeah, n is 10 here. And when we are popping 12, we'll know that it's a 10th number. Since each time we pop, we increment the count. And then we can say that this is our nth ugly number and we can return it. So let's code this solution. Okay, so what's the first thing we want to do is we want to make a priority queue, which is will have 1 at the starting. Now second thing we want to maintain a visited. So I'll maintain a visited, which is a set, and I'll visited dot add 1. Okay. Now what we want to do is, okay, this is a sort of recursive. So I'll do while true. We have to pop the minimum element. So minimum is our priority queue. So I'll do heap queue dot heap pop priority. This will give us the minimum element. After we have a minimum element, we have to generate these values. Okay. Okay, before that, we have to increment some count, right? So I'll maintain a count of ugly count is 0. Then I'll say ugly count plus equal to 1. And if this count reaches our desired value n, then we return the number we have to return, right? So the number is minimum only. Okay, so that was our return case. Now what we have to do, if it is not the nth number, we have to generate these values, right? So I'll just say for m in 2, 3, and 5, I'll just check if I'll just multiply it here. Product is minimum into m, and if product not in visited, we can add it. So we can add it to the first to the heap. So pq dot, oh sorry, heap q dot heap q dot heap push. pq is the name of the heap and the element is product. First is this, then we have to visited dot add the product. Second thing is this. Okay, so this what it will do is multiply it by 2, push it, multiply it by 3, push it, multiply it by 5, push it. Okay, and on the next iteration we'll get the minimum, and I think that should be it. Yeah. Okay, so it beats 49.8%, so it's pretty efficient. uh the time complexity for it will be, since we are going over n numbers only, right? So we went over these n numbers, and in the worst case we pushed these numbers unnecessarily, so which was our n times 3. So since that we ignore the constant, we say we went over the n numbers, and for each number we had to push and pop also. So both of these operations takes log n time in a heap. So our total time complexity will be n log n, and our space complexity will be 3 times n for this heap, or we can say n only. So yeah, thank you.